Here we are again at Fully Tech Mechanical. We're working on the Buick. I promised you guys some updates, and here we are. It's mid-April. Machine shop took their sweet time to get the stuff back to us, but it's back and it's in pretty good shape. We got a couple issues we got to deal with. Of course, with the wrong cam bearings, so we're waiting for that. So we're doing everything that we possibly can while we wait for Purolator to bring us out our cam bearings. So today we are file fitting our piston rings. This is a very, very crucial step. It's even more crucial on any engines with a power adder, whether it's nitrous or supercharger, or in this case we're putting a hair dryer on it. So let's look at a couple of things you're going to see when you gap rings, and actually a problem that we found here with our Total Seal rings. So I've gone ahead and highlighted the section of the Total Seal instructions. I always look at the stuff that the vendors send me. You never know if something's been updated or what the latest and greatest is, but ring fit is kind of a finished science. They figured this out a long time ago, what works. So you can experiment within these parameters, but I suggest you kind of start at the basics and work from there. So in this case, we're running a 3.8 Buick. Stock will run no more than 15 pounds of boost in this application. However, we're building this engine with the mind for, we're trying to build a very solid bottom end with an eye on increasing boost and performance in the future, potentially, at least so we don't have to go back into this engine and make any changes. So we're really building this engine to make no more than 20 pounds of boost in the future, even 25. So if you see in this case here, they're looking for a 15 pound of boost. We're going to do bore times 0.0055, and if we're going as high as 30 pounds of boost, it'd be bore times 0.007. So because our horsepower, our boost range is actually going to be a little bit different, less than the 30 pounds that the one formula gave us, but more than the 15 that the other formula, we split the difference, and that works out to bore, in this case, 3.815 times 0.00625. That works out to just under 24 thousandths of an inch. So the old Speed Pro rule of thumb was that you run a minimum 1/1000th larger ring gap on the second ring. So what we're going to do is sort of split within that again. We're going to run a top ring gap of 23 thousandths, a second ring gap of 24 thousandths. So while I'm working along gapping my rings, I start with my largest bore. So we've gone through this block, we've mic'd every bore, we've mic'd our lifted bores, we've mic'd our mains, and we're going through the cylinder bores now. And on this side we've got 0.2 of 1/1000th of an inch variance, which is kind of on the outside of the range of our measuring equipment, so it's a negligible number, but nevertheless we're going to start with the largest bore. That way, if we happen to file a little bit too much material off, we might be able to take that ring and put it in one of the slightly smaller bores and end up with the number that we want. Or we're going to throw the ring in the garbage and order another one. It happens. There's two types of people: guys that have taken too much material off of a ring, and liars. Anyways, so this is a ring right out of the Total Seal package. It has not been filed at all or touched. It's just been set in the bore and squared up. And we've got a 16 thousandths gauge, and that will not go in. We don't want to force it, but it should go in with a slight drag if it's going to go in, and it won't go in. So we're under 16 thousandths of an inch. Now we're shooting for 23 thousandths of an inch. So remember, this is a brand new ring right out of the package. If we were to put that in, even without any boost, that gap is going to touch. You're going to break a piston, and you've just spent $10,000. Now I'm old school. I just use a cheap manual ring file. I really can't file with one hand and hold the camera with the other, so I'm going to go and do this by hand. But I like the hand one because you can actually feel as it's cutting, and you can sneak up on it. I'll probably have a ring in and out of a bore about 3 times before I'm really happy with it. Something else I like to do is take just a nail file and go over the edges and take the burrs, any burrs off that the file will have left. And also I don't really want to work a chamfer, but I'm going to work inward away from the bore and inward away from the piston just slightly, just to make sure that we've cleaned that up Make sure there's not an edge. Again, I can't do that holding the camera. Now we've got our 23 thousandths gauge, and it's just going in, but it's a little bit tight. So we're really, really close. It's probably acceptable, but I'm going to put that back on the file and take just a touch more off, probably about 2 10,000ths off. And we've got it a little bit more filed off it, and it's in the bore and squared up. There's just that nice slight drag, so we are right on the money, 23 thousandths. Okay, so now it's time for the surprise. We found this about halfway through doing our rings. This is another ring right out of the package. I've looked at the end of it to make sure that maybe it hasn't been returned to a vendor or something like that. This has not been filed. It has the original flame cut texture on the end of right at the end of the ring. And this again is right out of the package, came with the same set. I've got a 25 thousandths, try to get that to focus, 25 thousandths feeler gauge. And it falls into there like a hot dog going down a hallway. Just nothing. So now what do? We can't put material back on. 25 thousandths, that's not that far off of where we want to be, but everything else is exactly 23. If this motor had to go out the door to go tractor pulling or doing something, and it had to go in a competition situation, we'd probably put it together and send it. But this sets off our spidey senses. Something isn't right with this ring. So what we're going to do, it's after hours, so we're going to call down to Phoenix Total Seal tomorrow. We're going to let them know the numbers that we have, especially when we saw all the other rings coming up at between 15 and 16 thousandths ring gap. This is in our smallest bore, so we've got no reason that we should have such a big ring gap. If I have to buy a ring, I'll buy a ring. This is not going in the engine. So we've got the time. This is why we do this stuff through the winter and into the spring, so that we can get it right. I'm sure Total Seal will take care of us. If we have to pay for it, we will. I have a feeling they'll probably send us a ring free of charge, but we'll find out. I think this part here on the instructions tells you the final story. If you're not sure, ask. We'll call the tech line tomorrow. We'll let you know what we find out. So the beauty of ring gaps and the fact that we file them is we can make these exactly the number we want. Some guys will go say plus or minus a thousandths, but I like to get right on the number. Things vary, parts get warm, parts get cold, so it's hard to really control that. So I try to do all my rings all at the same time, so at least the time I did them, they're all consistent. The shop is about 66 degrees right now. It's been that way all day, so I know that my parts aren't moving around. So I'm pretty comfortable with where I'm at. But something also to keep in mind is if you're working in your garage on the weekends and such, don't start first thing Saturday morning if the shop is below or around freezing, because by the time you're done the job, your block may have grown a couple 10,000ths of an inch, and that is enough to skew these numbers. Remember, we're shooting for precision. There's a lot of things that are out of our control. Bearing clearances and such are a lot harder to adjust, but in this case, we can get them exactly where we need them, and just by being patient. And in this case, we're probably going to be waiting about a week to get another ring. So the last thing I've done is I grabbed our second rings. I put all of them in one of the bores and made sure that my ring gaps on them are small enough to be filed into spec. So they're all, again, under 16 thousandths, so I've got lots of room to work. At least this way, when I call Total Seal tomorrow, all I'm going to be asking for is one silly piston ring. And if it costs me $15 or $20 to get it here, that's what it's going to take. We'll get this motor put together, and it'll be right, and it'll be fast.